We're asked to solve for these unknown sides in our triangle. Okay? So to do that, we can use trigonometry to help us. So we are given this angle 60, and using our calculator, we'll be able to evaluate 60, and that can help us find those missing sides. Okay? So let's start working from 60's perspective, 60 degrees perspective, and you can actually use any of the three trig functions to start, the three basic ones. Okay, look, from 60 degrees perspective, I have the opposite. Actually, one of them you can't use, but I have the opposite. And let's say I want to start with the beginning of the alphabet. I want to find A, side length A. So that would be the opposite divided by the adjacent, and that's the tangent ratio from our definitions. Okay? The reason for that is because this is the hypotenuse, right? And this is opposite of 60, so this has to be the adjacent. And the trig ratio that talks about the adjacent side, tangent of some theta, is opposite over adjacent, so it's tangent that we need. Okay, you could have picked C to start with. That would be opposite divided by hypotenuse. That would be sine, but we'll get to that in just a second. Okay, so if I'm doing tangent of 60, then I'm supposed to set it equal to what's opposite of 60, according to that formula up there, divide by the adjacent side, which is not the opposite, not the hypotenuse. So divide by A. And now I have an equation to solve. Because tangent of 60, I can figure that out with a calculator. Here's how I do it on my Windows calculator. I make sure it's in degrees. I type in 60, hit trig, and then there's tangent. So there's my decimal approximation. Okay, in other math classes, you might talk about how to find tangent of 60 without a calculator. So in order to get A by itself, it's in the bottom of a fraction. So what I want to do is I want to algebraically multiply both sides by A to cancel out A in the bottom. So when we do that, we get 1.73205008 A equals 10. So it's a little better now. A isn't in the bottom of the fraction. Now to finish getting A by itself, I want to divide both sides by 1.73205008. You probably don't need that many decimals. If you're my student, you probably know that I don't make students carry out a ridiculous amount of decimals or anything like that. Just a couple is fine usually. Okay, so 10 divided by that 1.732, I get 5.77. So that's roughly, it's an approximation, but that's roughly what side length A is. Okay, and now we need to know what side length C is. So we could use trigonometry again. You could use sine of 60 equals the opposite divided by the hypotenuse. That would work just fine. Or, what's a little quicker is the Pythagorean theorem. If you know two sides, you can quickly find the third side by plugging them in the Pythagorean theorem. And look, C is the hypotenuse, right? So I'm going to call this A and call this B. Oh, actually, well, it already says A, so let me call that A. It doesn't matter, though. Then there's B, and then E equals C squared. So now we just need to get C by itself, so 5.77 squared plus 100. So there's the left side of the equation. And then to get rid of the square, we need to use a square root to both sides. So square root this side and square root this side. So when we do that, we get 11.55. And that's what C equals. And now we found all the missing sides. They didn't tell us to find the angle, but if you wanted to, all angles add up to 180 degrees. So 180 minus 60 minus 90, that would give you angle A. Okay, so there's a question like this. They didn't draw the triangle for us, but that's all right. We can do it. Maybe I can't. Oh man, I'm so bad at drawing. So usually they let C be the hypotenuse. That tends to be how things are. I think in the textbook they might say that somewhere. So we'll call this A and call this B. You could swap those two letters, but C is usually the hypotenuse. So they're telling us the hypotenuse is 200. And they're telling us angle B is actually a measly 5 degrees, so I've drawn mine too big, but we can still do the math without it. So my goal is to find the missing sides. So I want to work with the angle that I know, or I could use the fact that all angles add up to 180 degrees to find this angle. But let's just use this angle. I want to find out what's opposite of this angle. And I don't want to involve the adjacent though, or else I'll have two unknowns in my equation. So when I use angle 5, I want to find the opposite, and I want to use the hypotenuse. That way I don't have two unknowns. So opposite, hypotenuse. If you go back to your trig definitions, that's sine. So we're dealing with sine in this problem. So sine of 5 equals opposite of angle B, according to my labeling. So that would be lowercase b. Divide by the hypotenuse of the triangle. Okay, so now we have an equation to solve for b. We can figure out what sine of 5 is. So 5, trig, sine, there it is. Carry out a bunch of decimals. And I want to multiply both sides by 200. Okay, so if I do that, I'll get b equals this stuff times 200. Right, because multiplying by 200 is the opposite of dividing by 200. So there's side length b. It's 17.43. And then once you have two sides, you can use the Pythagorean to find the third side, right? So it's a squared, which actually I don't know what a is. I'll put the square in just a second. Plus b squared equals c squared, but make sure to square each of those, okay? It has to be 200 because c squared is always the hypotenuse. So now we can solve for a by figuring out what both of those squared are. So roughly 303.82 for this one. And 200 times 200. So the quick way of doing that is multiply the non-zero numbers. 2 times 2 makes 4. And then there's 1, 2, 3, 4 there's 4 zeros after because there was 4 zeros in our multiplication problem. Okay? And now we can subtract. Here, let me double check though. Yep. So we can subtract the 303.82 from both sides. So we got 40,000 minus 303.82. So that's what the right side is equal to right now. Oops, that's from a different problem. I don't know where that came from. I can't type it in there. There we go. And then to get a by itself, I need the square root to cancel out that squared. So normally in math, you'd say plus or minus, but we don't care about negative measurements in this one. So I'm just square rooting that right side. So there, 199.24 is what it rounds to. That's what a is. So now we have all three sides.